Let's have a look at question 3 in this video. So we demand strawberries with this function, price equals to 4 minus 1 over 2q. Then, assuming that the income effect is negligible, how much are we hurt if the price goes from $1 to $2 per pin? So let's solve this. Let's solve it on a graph. What does it mean that we have this demand function? Let's draw it. The price and quantity. And we know that the price is equal to 4 minus 1 over 2 times q. Let's set our intercept so that we can connect them. The price intercept is 4, so we got here 4. The slope is a half, so it's going to be relatively flat. Now, what would be the maximum quantity? It would be the quantity that makes price equals to 0, so that would be 8, because 4 minus 8 over 2 is 0. So let's say something like that. Let's connect this to, and this is going to be our demand. Now, initially our price was 1, so price was 1 over here. Now, when price was 1, let's see what was the quantity. 1, we're substituting 1 into the price, so 4 minus 1 over 2 times quantity, meaning that if we change the places, we have 1 over 2 times quantity equals to 4 minus 1, which is 3. So quantity was 6. So the price of 1, we demand 6 pins. Okay, we got that. Now, what happens? What happens when the price goes to 2? When the price goes to 2? Well, obviously the demand is gonna fall. Let's see by how much. Let's calculate it. Let me zoom out, get some more space. So here. Now, when the price is 2, again substituting into our price function, 2 equals to 4 minus a half times quantity. Let's change the places of quantity and 2. So we have a half q equals to 4 minus 2. So a half times quantity equals to 2, which means that quantity is equal to 4. So we demand only 4 pins over here. Now recall, what are we losing as consumers? We're losing consumer surplus, because we used to have this benefit by paying less than what we're willing to pay, since our demand shows our willingness to pay. And it used to be that we had this consumer surplus at the price of 1, this whole triangle, this area, and now the triangle is diminished. Now our consumer surplus happens to be only this small triangle above the price of 2. So what we are losing is this whole thing. How can we actually calculate this? Well, we're going to subtract 2 areas of 2 triangles, and the difference is going to be our loss. So let's calculate the consumer surplus in the first case when the price is equal to 1. Let's do it over here, and then we'll do it when the price was equal to 2. So consumer surplus here is a half, because that's how we do the area of a triangle. A half times height and width. Now, what is the height? From 1 to 4, that was 3. And what is the width? From from 0 to 6, because we demanded 6 units. So times 6. 3 times 6, 18, divided by 2 is equal to 9. Now let's do the same for the other consumer surplus. When the price is equal to 2, what would be the consumer surplus here? Same thing, it's a triangle, so a half times the height. And the height now is only from 2 until 4, which is 2. And then the quantity is from 0 until 4. So 4. 4 times 2, 8, divided by 2 is equal to 4. We said that the difference between these areas is going to give us the loss in consumer surplus. So if we take the difference in consumer surplus, it decreased from 9 to 4, and that's 5. So we lost a benefit worth of $5. And that's it. We are done.